Hi, welcome to Coffee and Astronomy. I'm Jim Craig, and if you see me looking off to the side, it's because I've got notes here because I have tried several times to record this and I keep making mistakes. So I'm going to try to get through it without messing up terribly. Recently, a friend of mine posted on social media about Mercury, the length of its day versus the length of its year, and he said that its day is longer than its year. But in the things I had read, its year was 88 days. That's how long it takes it to go around the sun. But its day was 55 Earth days. It turns out that both of us are right, even though we use two different numbers. It has to do with what kind of a day we're talking about. It turns out there are two kinds of days when it comes to the way planets move through the sky and the way things seem to move through the sky as well. The day that most of us are familiar with is what is called the synodic day. Now imagine taking a line that runs due north and south and splits the sky in half. When the sun is exactly on that line, it's due south. Imagine it goes around and is on that line again. That's how we define a synodic day. And here on Earth, that's 24 hours. Well, it turns out that there is another kind of day. Instead of the sun, imagine it's a distant star like Sirius or Regulus. So we see that star on the meridian, and then we measure the amount of time that elapses before it's on the meridian again. It turns out to be about 23 hours, 56 minutes, 4.0905 seconds in length. So a little bit less than 24 hours. And that has to do with the fact that we're going around the sun, so we're kind of catching up with that star. And the stars rise and set 4 minutes earlier each night. Now, if you take that 4 minutes and you multiply that by 365 and a quarter days, you get about 360 degrees. So on the first day of summer, the summer solstice, whether you're northern or southern hemisphere, a star is going to be on the meridian. You come back on the solstice the following year, the sun is going to be on the meridian again. And it turns out that Mercury's sidereal day is 55 days. In other words, if there's a star straight over its meridian, it takes 55 days for that star to be on its meridian again. Its synodic period, however, is 176 days, which is twice the length of its 88-day year. So DJ was right about that. We were both right, and going to kind of pat ourselves on the back. And pretty much every planet has a difference between its synodic day and its sidereal day. For example, in the case of Venus, Venus has a 224.7 Earth day long year. Its sidereal day is 243 days. Its synodic day is 116.75 days. It's the only planet where the synodic day is actually shorter than the sidereal day, and that's because it rotates in the opposite direction. If you look at the planets from their north poles, the major planets, they all seem to rotate counterclockwise, but Venus, being different, rotates clockwise. So again, its synodic day is shorter than its sidereal day. Now, this makes a big difference when you're doing astronomy. Earlier, you remember I mentioned how the stars rise and set 4 minutes earlier each day. If you wait 15 days, that means that something rises an hour earlier. That's why you see different constellations in different seasons. But say, for example, you want to watch the Orion Nebula, but it's rising at 3 in the morning. If you wait 2 weeks, it will rise at 2 in the morning, another 2 weeks at 1 in the morning, and eventually it works its way around till it's rising in the evening, rather, the previous evening, so to speak, rather than in the following morning. So that's why you see different things at different times of year, and if you're patient, you will see whatever it is you want to find in the sky at some time that's more convenient for you. If you're a morning person, it can work out for you. If you're an evening person, it can work out for you. Eventually, it works out for everyone. Well, if you like what you see here, give me a thumbs up, make a comment below, consider subscribing, and if you really like what you see, consider becoming a patron by going to patreon.com, Planet of Mystery. That's patreon.com/planet_of_mystery. And for as little as $1 a month, you can help me bring these videos to you, get access to exclusive content. You can also go to the Planet of Mystery website at www.planetofmystery.com. It has links to the Patreon website, has links to merchandise, links to tutorials. You can send me an email. I'll be happy to answer your questions. So until next time, this is Jim Craig with Coffee and Astronomy, hoping you get out and enjoy the starry skies.